So now that we have already understood the definition, creation of a function, how it is being used, what is it being used for, when do we use it, what should we pay attention to, and the tricky aspects of parameter passing for both scalar values and structured values, and also function within function, we now come to a part of the appreciation for function where we look at a special category of functions called lambdas. Now, lambdas are called uh, kind of differently in some authors' presentation and some programmers. They are called the nameless functions, but lambdas are a little bit more stringent than having no names. All right, they must satisfy certain, or at least lambdas in Python must satisfy certain constraints before it can be called a lambda. So first thing first, for us to appreciate what is lambda, lambdas are functions. It's a very specialized subset of function. Now it is a function because it will take input parameters. Caller of lambda will be able to pass values into lambda. Remember, just take lambda as a function. And so there is a definition of lambda and a calling of the lambda. So it's exactly like function. We pass input variables, values into lambda, and the lambda will return a result. Remember, just like all functions do, they return single result. If you need to return multiple scalar values, pack them into a tuple or a list, and then return that single list. So it's always single value. Now, lambda is the same. It will always return a value. But lambdas do not have return word. You don't use the return keyword because a lambda is just an expression whose result is automatically returned by Python as the result of the lambda. So that does away with the need to explicitly return a value. Okay. What else? A lambda, all right, can define a function, a code like this. Lambda takes input parameter x and calculates x plus 10, so 10 plus x, and returns that value automatically. What uh, cannot be done is that you give a name to this function. So lambda of x has basically, that's it. It's a lambda, it's a function, a nameless function. And because of that, some programmers will call them nameless function. But remember, a lambda is not just that. Not only do lambdas not have any names to them, so you cannot have a name. I cannot point to the first lambda as function 1. I cannot do that. I will have to use def f1. Right? So I cannot point at that. It would just be a value created like that. And it's to be passed here and there until it is destroyed or it's being used or whatnot. It cannot have a name associated with it. Beyond that, all lambdas must only calculate and perform expressions. They cannot have side effects. What is meant by side effects? The chief culprit of a side effect will be assignment. All right, so for example, if you call a lambda and say set x equals to 2, you might say x is a local variable, and indeed it is, just like a function. It's a local variable, but it's not allowed because there is an assignment. Assignment changes the nature, the state of the variable. So you cannot have that. What you cannot have also will be the for loops and the while loops. You start with for, you start with while. All these will have state variables, right? The loop variables, which have to be incremental or decremental or changed in order to decide whether to end the loop or not. So you cannot have those. So for I in range, cannot. You cannot have a lambda that kind of prints out numbers from 0 to x minus 1. You cannot do that. You cannot have while set t equals to 0. That already is not allowed. Next statement, while x is less than 4, you cannot do that. No. So a while, a for, or not allowed. You cannot have if as well. All right, so because you have to somehow say if x is what, then return 4, but you cannot have return. So then again, if is also not allowed. So just keep in your mind, whether consequentially or directly, just you cannot have for, while, if, no return, no assignments. But then what can we do? But think of lambdas as a kind of your definition, your own calculation, your own creation of a functional expression that is behaving like square root, So I may have square root 2. Everyone understands what that means. Calculate square root 4. So I will get back a value. I always get back a value. Calculate square root 9. I get back a value 3. What if I want my own special square root, right? Calculate square roots, all right, and never give error. Okay, and so I specify my own error handling as 0. So every time there would have been an error, give me a 0. So for example, my square root is defined only for 0 to 10. And if you were to take a square root, my square root of a -5, it will give 0. Of 11.5, it will give 0. Anything beyond 10, it will give 0. Then that would work. That is a functional calculation. So that's just for example. Now, there are exceptions for us to use for, while, and if, but that is not to break the rules. In fact, it's still staying within the rules. Why? Because that is when we need to do list comprehension, dictionary comprehension, set comprehension. Then, such as the second example here, we'll define a lambda of x and create a list that is going to list out 0, 1, 2, 3 until x minus 1. Now that is allowed because this lambda is calculating a list, so that's a value. That's fine. It's an expression, valid expression. It's not a number, but in Python, value goes beyond just number and decimal places, right? It can be string, a list, that's still a value. So lambda returns a value that's allowed. And the for is actually a modified kind of for. It's not a control statement for, where the for is the starting keyword. This is a supplementary for just to generate the contents within the list. And so the final result is going to be a value, and that's permitted. Similarly, we can use while if we are able to initialize the initial value of the loop variable, right? So we know that while typically has to start with an initial variable to initialize the loop. If you don't need the initialization of variable, then a while loop may work, but usually it's for. Similarly, for if, you can also say use the expression form of if, not the control statement form of if. Control statement form will be starting with if and then elif or else, right? But the expression form of if starts with returning a value of 4 if the value of x is greater than 10, and otherwise else give me a 0. So it will sort of clamp the value of x to either 4 or 0, all right, depending on whether it's larger than 10 or not. And this form of the if, the expression form of if, that's what we say, is allowed in Lambda. And finally, if you have aggregating functions, that means functions that take a lot of numbers from the list or sets and combine them into a single number, certainly that's allowed. Like sum here is an aggregation function. It aggregates the list comprehension generated, all right, and then returns a real number, and that is allowed. So all the values are seen here. Yeah. Essentially, we need to create or define the lambda and then supply the input parameter. The way we supply, that is the way we call the lambda, is the same as a function. We just put a parenthesis there. But then, in order to be clear with the start and the end of the lambda definition, we typically put a bracket there just to be clear. All right, so the first bracket defines the lambda, like in the first line here. Then we call the lambda right away, and 6 will be substituted into x. 6 plus 10 is 16, and so the result is 60. So the idea is to sort of summarize the whole thing. The way to think about lambda is that you are creating your own customized function for your own calculation. Now remember, this is not necessarily just square root or my square root or number related functions. It can be list, and usually very interesting results and powerful applications of lambdas can be found when you use lambdas for structured data type and mixed type kind of calculations. So let's take a look at one such example where lambdas are very frequently used. It's like create temporarily this lambda function, use and forget, because remember, lambda has no name. Once you lose a pointer to that function, to that lambda function, it's gone forever. It's kind of lost in space. No one else can contain it because your only reference to that lambda function value has been lost, right? So it's used as a quick define, run, forget kind of situations, such as example like this. First of all, let me do a quick copy and paste screen over.